Bismillahirrahmanirrahim and Assalamualaikum to all students. Today we'll be learning new chapter 2, Logarithms and Radicals. Okay, where we will begin with 2.1 Logarithms. Few topics will be discussed. Number 1, introduction. Number 2, two types of log. Number 3, loss of log. Number 4, okay, change of form, meaning that you'll be learning on how to change from exponential form to logarithmic form. And the other one, logarithmic form to exponential form. Okay, and number 5, change of base formula. Number 6, property of equality. And the last one is number 7, single logarithm. Alright, so we will start with the introduction first. Okay, for introduction, okay, basically we write log s. Okay, so how can we read, okay, this expression? Okay, normally we read as, okay, log x base b. Okay, so if you can see here, we have a small letter of b. Okay, this is what we call it as base. Okay, and okay, the second one, we have, okay, two types of log. The second one is common log. Okay, what is common log? When you see log x is actually equal to log x base 10. Okay, by default, if you can see after this, if you are doing your exercises, you see log x, okay, doesn't stated any base here, so basically it means base 10. Alright, and second one, we call it as natural log. Ln x is equal to log x base e. Okay, so you have to take note that, okay, ln is equal to, okay, log, also log, but they contain base e. Okay, so I hope you can remember this. Okay, now we already discussed two types, okay, introduction and also two types of log. Okay, next we proceed with the laws of log. Logarithms, we have in total 6 law. Okay, number 1 we have here, okay, log 1 base b equal to 0. Okay, you have to remember, okay, each law stated. Okay, we can test. Okay, let's see, I have example. Okay, log, if you can see any base with log 1. Okay, let's say I have here 5. Okay, we can check. Okay, press your calculator. Log 1 divide by log 5. Okay, your answer will be 0. So we can see here, regardless any base, okay, log, the log has, okay, so meaning that if we have here log 1 with any base, they will be equal to 0. Okay, so you can try, okay, any base, let's say log 1 base 10. Okay, this one also equal to 0. Okay, this is law number 1. Okay, law number 2, when you see log b, okay, base b is equal to 1. Okay, you can test. Press your calculator. Let's say I have log okay, 5 base 5. Okay, how can we check? You can press your calculator. Log 5 divide by log 5. Okay, you can see we have a similar item. Okay, so means that we are dividing the same item is actually equal to 1. Okay, so this is law number 2. Okay, law number 3. Okay, log mn base b is equal to log m base b plus log n base b. So you can see if we have multiplication here, so it will be changed to, if you want to separate, okay, m and n, will be addition. Okay, from multiplication to addition. Okay, number 4, how about we have log m, okay, divide by n, so there will be log m base b minus log n base b. Okay, and number 5, we have log m power of p base b is equal to, okay, you can see we have exponent p. Okay, so you can bring it in front, so it will be p log m base b. Okay, you can see P in front of log. And number 6, we have B, power of log R base B is equal to R, where we can see we have the similar items here. Okay, so we have B and here we have B. This one is actually equal to 1. Okay, that's why the result here is R. So I hope you can remember each of these laws of logarithm, because of it is very important, okay, to solve the exercise later. Okay, this is item number 4. Okay, change of form. Okay, firstly we learn on how to change from exponential form to log form, where I have the first example. Here we have 2 power of 6 equal to 64. Okay, now I already numbering this, okay, where I have to change into log form. You can see here I numbering number 1, okay. 2 power of 6, okay, number 1 is 64. Okay, this is position for number 1. And then I have here base, okay, which my base now is number 2. Okay, and number 3 I put it equal to 6. Okay, now let's try. Okay, let's say I have the second example. I have 3 power of 5 equal to 243. Okay, remember the numbering. Okay, what I do is, okay, first, okay, log 243, and my base is now is 3 is equal to 5. Okay, okay, this is the 5th item. Okay, change of base formula. Okay, now we have formula log R base A. Okay, the formula is, okay, we can change this, okay, become log R base B divided by log A base B. We can see now we are changing from base A to base B. Okay, so for R will be the numerator part, okay, item for numerator, and for A will be item for denominator part. So I have one example here, log 8 base 4. Okay, now I want to change base 4 to the smallest number, which is 2. Okay, so what I did is I apply the formula. Okay, the formula is, okay, log, I have 8, and base, okay, I want to change to base 2, divide by log for base 2. Okay, now you can change the pattern. We know that now we have 2, so for number 8, we know that when 2 power of 3 will be 8, okay. So when, sorry. Okay, 2 power of 3 divide by log 2, and then 4, we change into 2 power of 2. Okay. And we apply law of log, so we can bring 3 to the front, and it become, okay, 3 log 2 2 divide by 2 log 2 2. Okay, so now we can see that these two value are the same. Okay, we have log 2 base 2, and now we have log 2 base 2, and this 2 is equal to 1 actually, right? So the answer left for this answer for this question is 3/2. Alright. Okay, this is the first example. Okay, this is the second example where I have log x plus 3 base 9. Okay, now I want to change from 9 to the smallest number. For number 9 is, we can factor out. Okay, we can use number 3. Okay, so the answer is equal to log, okay, x plus 3 base 3 divided by log 9. Okay, log 9 base 3. Okay, so we can also change the pattern, so it will be 3 power of 2, and you can bring it in front, so it will be log x plus 3 base 3 equal to 2 log 3. So we know that, okay, for this part is equal to 1. So the final answer is log x plus 3 base 3 divided by 2. Okay, so this is answer for example 2. Okay, next item number 6. Okay, property of equality. You can refer your book page 21. Okay, the example we have here 2 examples. Okay, but before we solve the examples, we have some formula for the equality. Let's say we have x equal to y. We have one equation, and to solve the value of x, okay, normally we will add log to the left side and another log to the right side. Okay, so let's look for the example. Okay, solve the value for x. Let's say I have here 3 power of x equal to 5, and I want to find the value for x. Now to solve this, you have to add ln or log to the left side and right side. So it will be ln 3 power of x equal to ln 5. Okay, x you can bring it in front, so it will be x ln 3 equal to ln 5, and x equal to ln 5 divided by ln 3. Okay, so this is the answer, where when you want to solve the equation involving exponential function, okay, you can use ln. Okay, this is the second example where you have to find x. Okay, now to solve this, you have to add ln to the left and right side. So it will be ln 2 power of 3x minus 2 ln 3 2x plus 1, and bring all of this, okay, the exponent to the, okay, front of ln. So it will be 3x minus 2 ln 2 equal to 2x plus 1 ln 3. Okay, why I put bracket here? Because of it involves two terms, okay, 3x and minus 2. This is to avoid careless. Okay, so now next step, you have to expand one by one. Okay, multiply ln 2 with 3x and ln 2 with negative 2. So we get here 3x ln 2 minus 2 ln 2 equal to 2x ln 3 plus ln 3. Okay, and then we can see here we have x and we have x. So bring x to the left side, it will be 3x ln 2 minus 2x ln 3 equal to ln 3 plus 2 ln 2. Okay, we just bring all the number to the right side and all the term contains x to the left side. And now we have to factor out x, and the answer inside the bracket is 3 ln 2 minus 2 ln 3 equal to ln 3 plus 2 ln 2. Okay, to find the value of x, okay, we bring all of the items here to the right side. So when we multiply, it becomes division. Ln 3 plus 2 ln 2 divided by all items 3 ln 2 minus 2 ln 3. Okay, so this is the answer for example 2. Right? Property of equality. Okay, and then now we proceed the last item. Okay, item number 7, single logarithm. Okay, single logarithm. So example 1, okay, write the expression as a single log. Okay, so now we have a2 ln a plus 3 ln b. Okay, to apply this to change, okay, now we have two terms, right? And now we only one okay, one log. So how can we solve this? You have to apply the properties or the law of logs. Okay, where we can see here we have number 2 in front and number 3. So what you have to do, you have to bring it back. Okay, and it will be, the answer is, okay, ln a power of 2 plus ln b power of 3. Okay, now we can see that we have here the addition. So apply law of log. So when we see addition, we know that this one will be a square multiply b b cube. Okay, so this is the answer where we only have one log, means this is single log. Okay, this is the final answer. Okay, example B, we have here 1 over 2 ln x plus 2 ln y minus 3 ln z. Okay, first step. Okay, you bring number to the back. Okay, so the answer here will be 1 ln x power of 1 over 2 plus ln y power of 2 minus ln z power of 3. Okay, so now we know that when we have addition, means we have to multiply. When we have this subtraction, we have to divide. Okay, so the answer is ln x 1 over 2 multiply with y square and divide with z square. Okay, so this is the final answer. Okay, other examples we have here. Evaluate number 1 log 9 base 3. Okay, to solve this you have to we know that we have now base 3 and we have 9, so change 9 to 3 power of 2, and you can bring 2 in front, so it will be 2 log 3 base 3, and we know that this part is actually equal to 1. The answer is equal to 2. Okay. Okay, example 2, we have here log 4 power of negative 3 base 4. So we know that we can bring negative 3 in front, so the answer will be negative 3 log 4 base 4. So all of this is actually equal to 1. The answer is negative 3. Okay, when this instruction needs you to evaluate, so you have to give the final answer in terms of number. Okay, any real numbers. Okay, another example. Okay, actually I just take all of the examples in your book. Okay, let's say now I have log 64 base 1 over 2. So now we can see here we have 1 over 2. You have to apply change of formula. So there will be let's say I change into 2. Okay, base 2, 64 divided by log 2. Here we have 1 over 2. Okay, so we apply law of 2 power of 6. Okay, 2 power of 6 will get 64. Okay, and divide with, we know here we have division, right? So apply laws of logs, will be log 1 base 2 minus of log 2 base 2. Okay, so next step, we can bring 6 to the front, so we get 6 log 2 divide by, okay, and then we know that, okay, for this part, log 1 with any base is equal to 0, right? Okay, no need to write anything. And here we have log 2 base 2 is equal to 1. Okay, now we put in the next step. The answer will be 6 log 2 base 2 divided by negative 1. Okay, so the final answer is negative 6. Alright, so I hope you understand.